Scenario: a cart is moving on a horizontal track in the positive x direction. A force acting parallel to the x-axis is exerted on the cart. The graph above shows the net force exerting on the cart as a function of time. Question: how does the momentum of the cart change during the time interval of 0 seconds to 2 seconds? The answer: let's set up the equation. Delta P, which is change in momentum, is equal to the force times delta time. Here, the time from 0 seconds to 2 seconds is 2. The force can be given in the graph. Notice from 0 seconds to 2 seconds, the force is a constant line on the 40 newtons. That's how they get that value. Plug in the values, you get the change in momentum is equal to 80 kilograms times meter seconds per second. Next question: how does the momentum of the cart change during the time interval from 2 seconds to 4 seconds? So that is from here, 2 seconds to 4 seconds. The answer: same equation, but this time the time is the same, which is 2. From 2 seconds to 4 seconds, that delta t is still 2. But the value here is constant at negative 24. So that's what they have in for F. You get the value of negative 40 kilograms times meter per second. The last question: how does the momentum of the cart change during the time interval from 0 seconds to 4 seconds? Rather than just redo the problem, you can just combine your answer from the top and the middle one. The answer: well, the momentum increase here, we saw that as 80 kilograms per meter second. Then it decreased here to negative 40 kilometers times meter second. If we add those together, you get a positive 40 kilograms times meter second. That is the total change in momentum from 0 to 4 seconds.